Hello everyone. Today I going to show you the real life use case of data science and ML. Today example is basically for the linear regression, and we'll use the linear regression to predict the house price. You can say smart house price prediction. I will try to explain it like hackathon way. How to if you participate in hackathon, how to build this solution. And our my guide will help you to understand the data science and also ML, how you can train your ML models. Here we will prepare the data, uh, handle the missing values, duplicate values, okay, standardize the data. So everything we have used. So one by one, I'll explain everything so that you can easily understand and you can build any solution and get hands-on. So let's start. So first, just traverse this deck. So for house pricing prediction, what are the challenges? In real estate, pricing is highly complex, driven by factors like area, geographical location, building age, and nearby amenities, and many more. The goal is build an AI-powered predictive analytics solution to forecast house price and minimal error. Data preparation, clean data, handle missing points, and execute exploratory data analysis or EDA. And that is last one is the ML modeling. Train and evaluate a sophisticated algorithm optimized against robust error metrics. Here I will train the linear regression model. As I discussed in the previous study that for linear calculation, I mean if the features are and target value are linearly connected, like if your room size is bigger, or suppose you have two bedroom, obviously the room price will be high. It's quite straightforward. I mean, a straight line relationship between the room size and or area with the price. So as I said, the data preparation includes the missing values, handle missing values, handle duplicates, select the important features. Okay, because in data set, for example, this is a one sample data set. Here you can see first column is property types, area, bedrooms, bathrooms, age, age of the building, parking, location, score, house ID, owner phone number, random code. It's maybe anything. Okay, for sample purpose I added. You can see these three column we can easily understand that these are useless, right? Because user owner phone number not linked with the price of the house. Similarly, house ID, because these are identifier, right? Okay, so that's why feature selection is also important. Also handle the outliers. Uh, we also verify the whether the outlier is exact outlet or not. Like for normal room price, like if a normal house, the price is normal. Okay, you can see this price very high because it's a luxury villa. So we need to identify whether this outlet is valid or not. Based on the our verification, we will decide whether we will remove it or keep it. And as that outlier is present, obviously we have to transform the value. I mean, not the values. Like you can use a log transform so that uh, reduce the extreme scale variation. I mean, we can normalize the value. And we have already discussed this thing in the previous tutorial video. Now, exploratory data analysis. So we will use a bivariate analysis. I mean, we'll compare any two features like area price, bedroom price to to understand which one is very I mean strongly related to the price. We also use the correlation to understand the relation with the I mean price with the different different features. So very important thing correlation. Also use the encoding because you can see the house price is the extreme value is present outlier. The price is this, but so for proper training we need to encoding so that price remain between 0 to 1. Yeah, as I said, we need to select the features. You can see the random code, house ID, owner phone number can remove because these are useless. We can keep area, bathroom, bedrooms, location score, property type. Yeah, that's very important. As I said, we need to standardize the values to make it in the same scale. Uh, because if we train the model with the raw data, so model will prioritize on the bigger values. Like you can see the area value is like bigger numeric value, right? For bedrooms 2, 3, 4 small values, bathroom small value. Then model will actually bias to this area because their values is very big. It will give more priority on these compared to the other things. So that's why we have to normalize all the values so that all are in the same scale. Their difference is not very large. So normalization of the data, I mean sorry, standardization of the data is very important before train your model. Yeah, we have to split data set into train and test. Some data will use for training and some data for testing. And we also use some baseline evaluation metrics like R square, MAE, RMSE. Okay, as we already discussed these things. MAE means absolute error. Is actually gives you the average errors And RMEC is a this you can say improved version of MAE. It actually highlight the big errors. Okay, and R square. So is the represent the direct proportion of the variance in the dependent variables predictable from our selected independent variable. Actually, R square tells us how good our model is. So we yeah, you use the RMAC to judge our model whether how good our model is. Okay, so lower RMAC means our model is good. So to improve our model, we'll use also random forest, random regress. The the random forest actually there are two types. One for non-linear relationship present there, and another for the linear data. It is random regress. As I said, feature engineering, advanced architecture used for to improve our model. This is a random forest regressor. As I said, so final flow is first we have to understand the business, then collect the data and clean the data, then find the outlier and EDA. I mean, it means exploratory data analysis. Then you have to feature selection, scale the data, then train the model and evaluate the model, and finally model optimization. In this tutorial, the deployment will not discuss. Actually, for to productionize your model, we have to deploy in the in the server. So this is the overview of the our solution, and in the next tutorial and the second part, I will go through the full code. Okay, to make the our tutorial shorter, I am just splitting this tutorial into two parts. So obviously, you should follow the second part. Otherwise, this tutorial will be incomplete. Okay, thank you.